Do you have difficulty with math? Worry no more, because I have a solution for you. Let's have math classes with Mamshi. See you in class! This time, let's discuss about real-life situations using exponential functions. The objective is, at the end of this discussion, the students will be able to represent real-life situations using exponential functions. So let's have here our generalization. Exponential functions are quite different from other algebraic functions, just like the linear and quadratic functions. The exponential functions is written in the form f of x equals 2 raised to x, and should not be focused with a linear function, which is like this, f of x equals 2x, nor with the quadratic function, which is f of x equals x squared. Notice that the exponent here is a variable, but for other functions, polynomial functions, the exponents are constant. So the exponential function with the base b is defined by this equation. F of x equals b raised to x. But since f of x is equal to y, therefore y is equal to b raised to x, where your b must be greater than 0. So your base must always be greater than 0, but not equal to 1, because the answer of y will always be 1 if our b is equal to 1. And also, x must be a real number. So population growth, exponential decay, and compound interest are some of the common applications in real life of our exponential functions. Let's have here our example. At the start of an experiment, there are 500 bacteria. Suppose that the bacteria doubles every 5 hours. So that is 500, which doubles every 5 hours. So give an exponential model for the bacteria as the function of t. So function of t is equal to 500 times 2 raised to t over 5. Why did I put over 5 there? Or why did I divided 5 from t? It's because it doubles every 5 hours. So we cannot just use t as 1, 2, 3, 4, 5, but it only doubles after 5 hours. So we have to divide the time with 5. So if we are going to check f of 1 for, f of 0, that is the initial number of bacteria. So 500 multiplied by 2 raised to 0 over 5. Take note that this will become 0. And so that is 500 multiplied to 2 raised to 0. So 2 raised to 0, and any number raised to 0 is equal to 1. So that will be 500 multiplied by 1. So initially, at time 0, the bacteria will be 500. So the population of the bacteria will be 500. Let's check if we try to have after 5 hours. So 500 will be doubled. So 5 divided by 5. That is 500 multiplied by 2 raised to 1. And 2 raised to 1 is equal to 2. So 500 times 2 is equal to 1,000. It means that after 5 hours, the bacteria will be doubled and it becomes 1,000. So it means that this will be the exponential model for our bacteria as a function of t. Okay, let's continue. Suppose the half-life of a certain radioactive substance is 20 days. So that there are 30 grams initially. So 30 grams that will be multiplied by 1/2 raised to number of days. So that is t over 20 days. Okay, that is the function of t. So our t here refers for the number of days. Okay, determine the amount of substance remaining after 40 days and give the exponential model for the amount of the remaining substance. So this will be the exponential model, and let's check if what will happen after 40 days. Okay, that is 30 multiplied by 1/2, 40 over 20. So 40 divided by 20, that is 2. So 1 half raised to 2 is 1 half times 1 half. The answer is 1/4. Or that will be 30 over 4. So 30 times 1/4, that is 30 over 4, or that is equal to 7.5. Okay, so there will be 7.5 grams of radioactive substance after 40 days. Let's continue. The compound interest is given in this equation. Okay, A is equal to P multiplied by 1 plus R raised to T. Our T here is a number of years or the time. R here represents the rate. P represents the principal amount. And A represents the future value. Okay, or the money that you will have after investing in compound interest. So Waling Waling invested 500,000 in a company that offers 6% interest compounded annually. So this will be our R. 6% in decimal will be 0.06. And define an exponential model for this situation. How much will this investment be worth at the end of 5 years? So our A will be equal to, the P is equal to 500,000 multiplied by 1 plus rate, which is 0.06, multiplied by time that's raised to time. So our A is equal to 500,000 times 1.06 raised to T. This will be the model. And to find the worth after 5 years, we will have 500,000 multiplied by 1.06 raised to 5. And 1.06 raised to 5, the answer is 1.34. So our A is equal to 500,000 multiplied by 1.34. I just limit the decimal place into 2. So I just round it off. 500,000 times 1.34. That is equal to 670,000. So after 5 years, your 500,000 will be 670,000 if it has an interest that is compounded annually for 6%. Okay, let's continue. We have here our enrichment activity. A certain municipality has 2,000 individuals and its population doubles every 6 years. So, if we have to solve this, we have f of x equals 2,000 individuals, which doubles every 6 years. So, t over 6. Give an exponential model for the municipality, and what is the municipality's population, okay, after 5 years. So all we have to do is substitute. Sorry, it's not f of x but f of t, where your f of t refers to the population. So f of 5 equals 2,000 multiplied by 2 raised to 5/6. So that will be 2,000 multiplied by 2 raised to 5/6 will be equal to 1.78. So 1.78 multiplied by 2,000, the answer will be 3,560. This will be the population after 5 years. Let's continue. Kabalikat Cooperative offers 3,000 annual interest rate, compounded annually, for a certain fund. Give an exponential model for a sum of 30,000 invested under the scheme. So, our A is equal to principal amount multiplied by 1 plus rate raised to time. So that is how much? That is 330,000 multiplied by 1 plus the rate, which is 3%. So in decimal, that's 0.03 raised to time. So our A will be equal to 30,000 times 1.03 raised to time. And since we are to find it after 10 years, so we have 30,000 times 1.03 raised to 10. And 1.03 raised to 10 is equal to, let's just round it off into 2 decimal place. So we'll have 1.34. Okay, so 1.34 times 30,000, our final A must be 40,200. Okay, so 1.34 times 30,000, that is 40,200. This will be the amount of money in the account after 10 years. Okay, let's continue. The half-life of a radioactive substance is 500 years. If the initial amount of the substance is 500 grams, give an exponential model for the amount remaining after t years. So the half-life will be equal to, let H be the half-life, the remaining amount of the substance, so that will be 500 grams multiplied by 1/2 every 500 years. So the number of years, let's put it as T over 500. So what amount of the substance remains after 100 years? So all we have to do is substitute that. Okay, the amount H equals to 500 times 1/2 raised to 100 over 500. And that is 500 multiplied by 1/2 raised to 1/5. So let's solve. 1/2 raised to 1/5. The answer will be equal to 0.87. So that is 500 multiplied by 0.87. The answer will be 435 grams. So the amount of the substance will be 435 grams after 100 years. Okay, so we are done with quarter 1, week 5B. For those who are new to my channel, just subscribe to my channel, click subscribe, and hit the notification bell to be updated of my latest videos. Thank you for watching, and I hope you learned a lot from me.